welcome to our Quantum Black Careers in Data Analytics session. We're delighted to be collaborating on this fantastic event with the Ada Scotland Festival, and thank you for making the time to join us today. My name's Helen Mullings, and I'm Head of People for Quantum Black, and it's my pleasure to host today's session. In a moment, I will introduce my four fantastic colleagues who will be talking about their different roles and career journeys. But first, a quick introduction to Quantum Black and why we're hosting this session today. Next slide, please. So, Quantum Black was founded about 11 years ago by 3 people working in the Formula One industry. At that time, Formula One was already using advanced data analytics to improve race performance. And our founders realized that these approaches could be equally applied in business to raise performance to new levels. 4 years ago, QB was acquired by McKinsey, and since then we've been able to support an ever-increasing list of global corporations on their journeys to use data analytics to drive performance. Next slide, please. Improving business performance is important, but at QB we want to have impact beyond that, and we believe that much of the work we are doing also has a positive impact on human life. For example, we're heavily involved in the healthcare sector and have used data analytics to improve patient outcomes or to help get life-saving drugs to market faster. AI is an incredibly complex field, and as we've all seen, it's very easy to get it wrong. So we invest heavily in research around ethics and fairness to ensure we help our clients navigate this world in the best way possible. Next slide, please. So why are we here today? Our industry has a problem. Women are seriously underrepresented in the data industry, especially when you look at technical roles and at the more senior levels. And this is a very serious issue, especially if you think of a world where men are predominantly writing algorithms that will impact women's futures for many years to come, or where the average wage in data analytics is more than twice the national average. Women are missing out. Next slide, please. Actually, no, sorry, hold there. For the last 3 years, QB has been working hard to improve its own gender mix. And I'm pleased to say that last year, 50% of our data science recruits were women. But we also need to help our industry more broadly improve representation. So we organized today's event to give you some insight into the roles available within a data analytics company, and for you to meet some of our remarkable female colleagues and hear their career stories. We hope it will inspire you. I'm now going to introduce my colleagues. We will have a few minutes at the end for questions, so if you'd like to post any questions in the Q&A function of the webinar as we go through, we can address those at the end. But first off, I'd like to introduce you to Meryl, who is a software engineer at Quantum Black.
Hello, everyone, and thank you so much for joining us today. I'm really excited to share my journey into software engineering and explain you a bit about what a software engineer does and what I specifically do at Quantum Black. So when I went to university, I didn't know yet I wanted to be a software engineer. I wasn't familiar at all with coding or what it meant to study computer science. So I actually went and studied liberal arts and sciences. And this was an amazing degree because I could choose a lot of different modules in different fields. So I did a bit of neuroscience, film history, psychology, and especially in my first year, I tried out a lot of different things to really find my passion and my career for the future. And so during my first year, I took a course called Programming Your World. And it really excited me because it was all about solving problems and writing algorithms, which, because I liked mathematics, I thought would be really good for me. But then one thing that really surprised me in this course was that it was super creative as well. And I never really thought it would be. I don't know why, but in my head it was kind of similar to maths, where when you kind of know how it works and when you understand it, you just apply that knowledge over and over again. But actually it turns out in coding, you have so much freedom to build whatever you want. So it's not just one form fits all. You can build anything that comes to mind. So this was something that really sparked my curiosity, and also the reason why I decided to continue in computer science. So when I graduated from my undergrad, I decided to do a full master's in computer science at UCL. And this was only, it's only a 1-year master's, but it was really good because it dealt with a lot of the fundamentals in computer science. So I learned about hardware, I learned about software, things like databases, like how do you store data. So it's really good for me to get a bit of foundational knowledge about what is computer science. And then when I finished that degree, it was kind of a confirmation for me that this was the right path I was on, and I definitely wanted to continue. So I decided to look for a role in software engineering. And I must be honest with you, at this time, I still didn't really know what a software engineer did. So that's why I kind of want to spend some time explaining to you what the role of the software engineer is. So if we can go to the next slide. Yes, so first of all, I think it's important to explain what software is. So when you look in the world around you, like your smartphone, your computer, they both contain hardware and software. So the machine itself, the smartphone itself, robots, all these kind of things, they're hardware. They're the machines that run code. And then the code itself, so the thing that makes apps work, websites, all these kind of things, they're software. So the job of the software engineer is to write the code for all these different applications, all the websites, all the kind of things that make machines run in a way. So of course, the most important part of your job as a software engineer is to write code. And those can be new features. So it can be that you have to come up with something completely new, and you have to decide yourself how you're going to write the code, where the code is going to be, and which algorithm you're going to use. So you have to come up with that all yourself. And then a big part of your work will also be testing the code you've written. And the reason why this is important is, as you can imagine, if people are using your code in real life, of course they want it to work well. Like, it's very frustrating if some of your favorite apps just shut down or they don't load. So when you are writing the code, you want to make sure that your users will be happy with it and they can trust it. So they know if they've saved something, it won't be gone the next day. So it's very important that you write tests to verify that your code is actually doing what it needs to do. And then there's also a big part where you're refactoring existing code. So that means you go into code that someone already wrote. So it could be you wrote the code, but it could also be that some member of your team wrote the code. So you have to be able to adapt existing codes to fix it if it's broken, or to even include new things in there. So you need to know how to adapt it and read someone else's code as well, because it could be that the old code isn't yours. So part of coding is also understanding how other people code and what that means. And then with coding also comes reviewing of coding. Because when you can imagine, especially if you work on a very important big system and there's lots of bits and pieces, you cannot just write it and then put it in the live app and let it live there. You need to get some verification from your team that what you did is actually properly done. So as part of my job, I also have to review my teammates' codes and make sure that what they wrote is good and I actually understand it, because it might be that in the future I have to go in and change their code again. So I have to make sure that I actually know what they mean. And then also a big part of my job, or of any software engineer's job, is collaborating with others. Like, we're not just sitting in a room coding away and, like you see in some of the movies, that's not really what you do. You definitely work with a team. I talk to my team every day. Like, we have ceremonies. So for example, each morning we have a catch up where we talk about, well, first of all, how we're doing. And then second of all, what we're working on, whether we need some help, whether we have questions on anything. And then we also have bigger technical design discussions and like brainstorming sessions. So for example, if you're working on a very complicated problem, don't worry, it's not just on you. You have a whole team to work with and to talk to, people that can help you. Yeah, so let's go to the next slide and I can tell you a bit more about what I do specifically at Quantum Black. Because being a software engineer can be quite different in different companies. And I feel like being a software engineer at Quantum Black is quite special. The first reason for me right now, I'm working on a project called Kedro. And Kedro is an open source project. This means that everyone in the whole world can see the code, they can contribute to the code, and they can use it. So first of all, your users are suddenly like the whole world can use this product, which is really exciting. But it also means that people from the outside world can contribute. So suddenly your team of software engineers is much bigger. It's not just the colleagues within the company. It's anyone who wants to add something or maybe improve something. So you also learn a lot more because of course different people have different perspectives. So it's very cool to be working on an open source project. Then second of all, I code in Python. This is not very specific to Quantum Black, but Python is one of the major programming languages. It's very popular nowadays, especially in the world of data science. And for me personally, this is also the first time I've coded in Python. And if you feel like you're interested in computer science, you will probably come across it very, very quickly. Then another thing that's quite special to my role as software engineer here is that I collaborate really closely with my users, and both to help them solve their problems. So it could be that someone who is using Kedro, they have a question because something isn't working, and they can come to me and I can help them with that. Another thing is that our users are actually data scientists and data engineers. So for me, it's really cool to learn about how they actually use the product and what they do on a day-to-day basis. And then finally, I also get to ask questions to my users. So I get to conduct user interviews to get feedback on the product. So it's not just them asking me for help, but I can also reach out to my users to get feedback on if they think the project is working well or if we need to improve things. So really make sure that what I'm building is actually worthy and people are benefiting from them. And that for me is just one of the most important things, that I know that the code I write is actually relevant to people and people like the project. So in a nutshell, that's what I do at Quantum Black. I hope you learned a bit about what it means to be a software engineer, and enjoy the next sessions.
Thank you very much for that interesting presentation, Meryl. I think one of the really important things I took away from that is that being a software engineer involves a lot of human interaction as well as interacting with the computer keyboard. I think people often associate tech roles with being very individual, but actually they're extremely teamy and involve a lot of people as well on a daily basis. Moving on now, I believe we have Hong next, who is a front-end engineer at Quantum Black. Over to you, Hong.
Thank you, Helen. Thanks, Meryl. So hello everyone, my name is Hong Nguyen. I'm working as front-end engineer at Quantum Black. I will briefly explain to you what actually my day-to-day job, but before getting to that, I might talk about a bit my background. So I graduated in international business at the University of Gloucestershire. And I think I was quite similar to Meryl when I started to thinking about university. I wasn't sure what I wanted to do. So I thought I would choose business so I can get kind of an idea of what the world is out there doing. And then, so I did, I finished 3 years with the international business. And after that, I decided to get a career in advertising. So I went on to work for TBW and Ogilvy as an account executive, where my main job was to help clients to build TV advertising or like all the billboard you see on the street. So I worked at a company for about 1.5 years. And then there was quite a turnaround in my career. So I started, like, I realized that I actually wanted, wanted to build a career in technology, because I felt like I really interested in, like, to see how, like, a software work. But specifically, I was really interested in, like, building website. So Code First Girls, I joined the web development course Introduction by Code First Girls. I just kind of, like, it's run only for 3 months, kind of give me an overview of what actually web development looks like. So after 3 months, joined the course, and then I realized that, well, I really want to get this as my career. So then I went on to do other courses, and then later on I started applying for jobs, and then and then I found my dream jobs at Quantum Black, and I'm now working as front-end engineer. So what does front-end engineer actually do? So front-end engineer is also a software engineer, as how Meryl explained, but what we build, in terms of what we build, is slightly bit different. So my day-to-day job is, like, to build and then maintain all the visualization that on the website. So what that means is, like, when you go on the website or any web application, everything you see on that, including layout, design, button, navigation bar, all the interactions, like where you can move stuff around, that's pretty much what I build, so that I can build an application so that you can go as a user, you can interact with it and play around with it. And by doing that, one of my day-to-day job is to help deliver the user experience. And what that means is, like, when you go into the website, I need to make sure you have the best experience on the website. Like, if you click on that button, and then it will clearly show you what the next section would look like, or, like, all the colors, would that be helpful when you, let's say, is it in the morning or is it in at night? So there'll be, like, different colors. I need to make sure it runs smoothly and help you have a good experience when you were on the website using it. And as a software engineer, I need to always make sure my code is met the best software quality, and so, like, do testing, make sure, like, as Meryl explained earlier, like, do testing, make sure I do reviews my code properly, and work with my team. But so what skills do I need to do my job? So in order to do web development, there are three main technology that I use every day. The first one is HTML, which is the markup language, where you use that to build the structure for the website, how you want to do that. So imagine if you have a book, and then if you want to write a book, you need to define, like, what would be the title, what would be the first section, the first chapter, second chapter. So it's kind of HTML to build the structure of the page. And then I've used CSS as the styling language to add, like, colors, font size, different theme, background, interactions. So I'm using CSS to do that. And then JavaScript is one of the coding language that I use to build the web development, where I include, like, all the interaction. Let's say if you click on that button, you will see all the pop-up come up on the screen, or if you click to that button, it will show you the video. So that I'm using JavaScript to make that functionality work. The next thing that I had to learn during my job is version control. I use Git. So you can think of version control is like a thing to help you control and manage your code. So let's say today you make changes on that line of code, and then tomorrow you decide, or you might want to go back to the previous version of that code. So then the version control will help you decide, oh, so today you change that, yes, tomorrow if you change something, it will have, like, all the information for you, so you can easily go back to decide which part of the code you want to go back. And apart from all the technical thing, I also need to learn about user experience, which is how do I understand my users? Like, how do I know what my user wants? What will be the best thing for my user to go to the website? So that's what is called user experience. Agile is ways of working, and just the ways of the team will work. Like, let's say instead of like building a website, like you build the navigation bar, you build, and then next you have to move to build a title. But then working agile, maybe you can say, maybe I can, in order to get the user to use my website in the quickest timing, maybe I could build a title first, because when you go to the page, user need to see the title is more important than the button. So then by working in agile, I can make that decision quickly. And yeah, and then as Meryl say, my day-to-day job is pretty much like trying to solve a problem. So let's say, just if user have some issues, I will sit down with the design team and then think of what the best way to help user to solve the problem. And then I will implement it by using the code to make it work. And yeah, teamwork, because I can't just build something on my own. So I need to speak to the designer team, different people from different team at my work, to make sure I understand what the quality or what are the requirements there for me to do my work. So that pretty much the brief introduction to what I do at work, and then what sort of skill do I need to do it. So move on to the next slide, please. So, so as I say, I started with business as my degree, and then I went to do advertising, and then I started building like interested in technology, and then I was like, so I need to improve my skill, my technical skill. So, so I chose to go on do some online courses, because it was always available out there. I can do it at home after my work, and then it's free as well. So I found I actually did loads of different workshops, or like for example, Code First Girl, or like I did loads of like online learning platform like Code Academy. I actually learned coding on YouTube, and then I build on joined Katathon that to do like some website together with other team member. So that's where I build up my experience and learn the code along the way. As you can see, there's a lot of things available on the internet, or even in event that you can join as well. Can I get a next slide, please? So, so there was a lot of all the resources that I use. So if you're interested in that, I actually made the web page where I share my experience, my thoughts, and also the link to all of the events or online platform that I use as a link there. So if you're interested, you can find out more information through the link. Can I get to the next slide, please? So, so as I say, I'm working as front-end engineer at Quantum Black. So I was thinking maybe I should speak a bit more about the products I'm working on. So I'm working on the products at Quantum Black called Studio. So Studio is a web application, but it's slightly different from the normal web application you would think you would normally interact with in daily life. So in Studio is the product where I build to help my colleagues or the client team to manage their workflow by building all the visualization on the web page. So what actually workflows? So workflow, you can think of it as like a to-do list, like where you define what is the top prioritized, what you want to do today, what you want to do tomorrow, or what you should do, what you should really get done this week or next month. So it's a workflow. Or I can also, I'm using visualization. By doing that, I help to translate all the complex data set into like cool charts, visualization, like a chart. You can see there all the lines are connected, or like circles to help translate all of that into like very easy to understand visualization. And the cool thing about Studio is that you'll be able to interact with it. You can decide, if you decide, oh, maybe I should test out by move up down item, it will reflect immediately in the visualization. And you can also import the data directly into the application, so you don't have to type it down. Or when you've done everything, you can download it directly from the web page, and it will in the format of an image for you to ready to see it, or you can save it, you print it off. So that's what eStudio is about. So I have working on like loads of things like hypothesis tree, data. So it's pretty cool. So you can think of hypothesis like an idea or an explanation of something where you need to note it down. So instead of like have to write it down on the paper, we have like all the cool visualization. Like you can see the one in the middle where you can check out like what is actually linked to each other. So you can, it helps the client team or our colleagues to do all the brainstorming. So that's pretty much about what Studio does. So if you ask me what have I learned during my career working as front-end engineer at Quantum Black, I actually learned a lot of things. The first thing I've learned is how do I deliver like the best practice in software development, and what Mero explained earlier is literally what I follow every day. And apart from writing code and building software, I also have to think about how to solve a problem how would I design the code based on like the user point of view. And also Quantum Black have also taught me about advanced analytics, about like all the data, the complexity of it. So I have learned a lot through my job. And the last thing is because our team is quite global. So we have different offices, different locations. So I have a chance to interact with people from all over the world and then learn how to work with them collectively. And I think it's really awesome for me to learn as well. And I think it's pretty much the brief introduction from myself about my job and what I do at Quantum Black.
Thank you so much, Huong. You know, certainly a couple of reflections from me here. One is that, you know, you don't have to study computer science at university to get into coding or to get into a career in tech. There are many ways in. I'd particularly shout out the organization Huong mentioned, Code First Girls, which is another organization that Quantum Black supports, who teach women to code and enable them to enter our industry. So do have a look at them. And then the other thing I would observe from what Huong said is how creative her role is, and how she really is bringing together technology with, you know, design and to some extent art in the, you know, often quite beautiful front ends that our front end engineers build. Moving on to the next talk now, we are going to be joined by Farah, who is a relatively newly joined data engineer at Quantum Black. She was actually brave enough to join us, I think, without almost having met us during this working from home lockdown phase that we've all been living through. So over to you, Farah.
Yeah, thank you, Helen. So hello everyone, my name's Farah. I'm a data engineer at Quantum Black. As Helen said, I joined in April, so I've only physically been to the office for 2 days, but nonetheless, having an amazing time. Let me tell you about my backstory. So after I finished school, I went to Imperial College London to study biochemistry with management. So similar to the other two speakers so far, I did not know going to university that I was going to end up in a job like this. I didn't learn to code at university. I actually learned that later on, so don't feel like you have to pin yourself into something specific when you're studying. There's always options to learn later on. So then I got a job in a marketing agency, and actually that was how I figured out I wanted to go into data and analytics, because I found myself kind of naturally gravitating towards the analyzing of our marketing campaigns and trying to figure out what was working and what wasn't. And so from there, I made the decision to join Kubrick Group, which was my next employer, which is a data consultancy. And so there they had a training program. That's where I started coding. And from them, I got 2 placements inside big companies where I continued my data learning. So the first one was in the music industry, and then the next one was in an energy company. And then from there, I ended up at Quantum Black. So I'm going to tell you a bit more about my time at Quantum Black so far. I'm going to tell you about one of my recent projects in pharma, and also some of the internal research and development that I've worked on. But just to quickly highlight that, from looking at my history, you can see that working in a career like this, and like any of these speakers are going to tell you about their roles, you can hop between industries with the same skill set. Like being a data engineer allows you to work from anything from the music industry to pharma. Like, so it's a pretty, that's one of the reasons it appeals to me a lot. So if that's the kind of thing you're interested in, you should definitely consider a career in tech. So can I have the next slide, please? Okay, so what is a data engineer? Data engineer, it has quite a lot of different types of activities that they do. So first of all, when you start on a project as a data engineer, it's your job to figure out what different data sources there are, figure out how easy it is to get hold of them, how like feasible it is to use them. You have to think about the security measures that need to be surrounding data sets. So obviously there's a lot of strict rules around personal data. So you've got to make sure that you're considering that if you're going to work on a project involving people, like data about people. You've got to think about how you're going to ingest them. Ingesting is it's a word that you might not associate with tech at first, but ingesting just means like sort of process it into your code. By the way, if there are any questions that any of us use, any words that any of us use that you don't understand, please feel free to also ask in the Q&A. There are no bad questions. So yeah, ingesting the data, looking at the quality, seeing what you've got basically, and from there, that's what allows you to build a pipeline. A pipeline is essentially what we call some code or software that takes the data, usually moves it to some sort of storage. You might do some transformations if you have any calculations, if you have any cleaning that needs to be done, which means basically sort of if there are any mistakes or punctuation that you don't want, you might get rid of that. All of this is with the goal of being able to analyze the data better, to be able to use it in some data science models. The whole purpose of having data engineers, data scientists, and data analysts is usually to answer some sort of key business question. So I don't know, a shop might go, which product should we sell more of? And then we as the data team might dig through all of their records of all the different sales and transactions they've had and try and come up with an answer using the data. So that's kind of like a high level example of something that we might do with the data. So what else do we have? We have the data storage decisions. So obviously there's lots of different ways that you can store data, different file formats, different locations that you can store data. You might have heard the phrase in the cloud versus on a local machine. So that's the kind of decision that a data engineer would need to get involved with. On the cloud basically means that it's saved into in lots of different places, so you can access it from anywhere on the internet. And finally, we might also be involved in some sort of visualizations or reporting aspect of the data project. So lots of different activities, similar to the previous two speakers as well. We would be involved in lots of meetings and like talking in a team collaboration setting to figure out how to answer these questions using data. So next slide, please. I'll just quickly explain like one of the examples of a project I recently worked on. So this was pharma. Pharma means pharmaceuticals. And so when a new medicine is developed, there are obviously lots of rules around what kind of advertising can be done to a medicine, but there've got to be some level of promotion to make sure that, you know, when it's appropriate to prescribe that medicine, it does actually come to the mind of the doctor, so that they know about it. They've got to know that it exists in order to prescribe it. So this project was about figuring out the best ways that you can sort of make sure that the doctors know about your new medicine. So this project was basically it had aspects of all of the different things I've mentioned. There were lots of different types of data sources, and we wanted to be able to get them in a format that we could use in a data science model to run algorithms on it and figure out the answer to that question. So here on the right, we've got a bit of a diagram. We have lots of different layers of data is how we call it. So basically the raw data is the data that you get straight from the source. So that might be an Excel file, it might be a big database, it could be lots of different things. The primary data is when we've kind of cleaned it up and we've got an idea of what we want to do and what the useful parts of the data are. And then features are what you're going to feed into the data models, into the data science model. So you've kind of got an idea at that point of the things that might be useful to answer your question. So all of this, obviously, during COVID world, it's all been remote. So that also adds different aspects to a data project. Often there are very strict rules about where data can go and where it can move around between different companies. So we had to have a system to be able to log in virtually to the pharmaceutical data so that we didn't move it anywhere it shouldn't go. We worked, here I've got another point about working on Azure. This is where we were kind of, as a team, all creating code for this pipeline that moved the data along. And we also do the system that Meryl was referring to about reviewing each other's code, making sure that everything looks good, making sure that everybody has good oversight of what's going on in the project, everyone's up to speed. It was also written in Python and PySpark using Kedro, which is actually the software that Meryl was working on. And here I've written about all the different types of data sources we had. So yeah, there's some things in Excel, there's some things in what's called an Amazon S3 bucket, which is an example of a place you could store it on the cloud. Yeah, so we processed all of this data, could put it into this data science model, and then that allows us to give a good attempt at answering the question of the best type of sales activities for this company to do. So next slide, please. Other types of things that you might do as a data engineer is internal research and development at Quantum Black. So the idea of this is basically if there are activities that all the data engineers need to do time and time again, then it's probably a good idea to try and write some ready to go code that will help you do it quicker, so that we don't all have to write it from scratch every time. So an example of that is for data profiling. Which is basically what we call trying to get an idea of the data. What are the minimum and maximum values that are there? Are there a lot of what we call null values where there's no data there at all? All that kind of thing. So that's the kind of thing that everyone needs to do at the start of a project. And so we try and write Python packages that will help people do that quicker. So lots of different things that you can get involved with as a data engineer. And I think that is everything I was going to say. So thank you very much.
Thank you very much, Farah, for lifting the lid on the data engineering role, which is sometimes perhaps one of the least well understood roles in the kind of analytics universe. Now moving on to a role which is perhaps a little bit more familiar to a number of people at least, and that's the data science role, and going to be joined by my colleague Margot, looking very fetching here in her hard hat. I'm sure she'll explain more about that in a minute. Over to you, Margot.
Thank you very much, Helen, and hi everyone. Thank you so much for joining us this afternoon to celebrate great women like Ada Lovelace, the first computer programmer. So as Helen said, I am a data scientist at Quantum Black, and today I would like to give you a sneak peek of what it is to be a data scientist at Quantum Black, illustrating this with a project which I carried out to increase production of a medical device. Before that, though, I would like to walk you through my curriculum and my journey to data science, because just like Farah, Huang, and Meryl before me, it was not really a linear journey. So you might notice in my curriculum that, yes, I did study maths and statistics, and this was actually a topic that I enjoyed since high school. However, I had two turning points in my career which really decided this journey in data science. The first one was in my last year of high school, just before the A-levels, or baccalaureate, as we call them in France. And this is because I had a great physics teacher, but before meeting him, I thought I would study international business, so not a very technical role. And he really determined my position in science. And after having him as a teacher, I really decided that I wanted to study maths, physics, and continue in a more engineering journey. And further to this, I had the opportunity to graduate from Télécom Paris Tech. And this is a very computer-heavy education. So it's a school where you study computing and maths. But before joining the school, I had never programmed, and I never thought I would. And I started my first year surrounded by people who had already opened up their computers, who knew everything about operating softwares. And I didn't know any of the vocabulary, so I felt completely lost. So my first interaction with programming was actually not great, not friendly, but I gradually went there. So if you have any questions about this later on, I'd be happy to answer them. Just become graduate. So this is a bit about my education, accelerating a bit fast forward to my career and when I started working as a data scientist. I started in Paris at Bearing Point, and then when I wanted a more challenging and international career, I joined Quantum Black in Sydney and then in London, where I am based now. As I said, I am going to walk you through the journey of a data scientist at Quantum Black, and I would like to start by saying that usually we carry out projects across many industries. I'm going to focus on pharmaceutical manufacturing, which is production of medical devices or vaccines, drugs, which I find fascinating. And usually we split projects in 3 main stages. So maybe if we go to the next slide, you can see this very practically. As you can see, a project will last on average 3 months. And we usually start a project by scoping or determining what we're going to study. And very often a client will come to us and say, oh, I have this issue. I have identified that my production is not very efficient. I know I can leverage the data to increase my production or to reduce some times in the process, but they haven't really spotted what they can model. So this first stage here is fundamental because this really determines what we are going to model. Are we looking to increase or other types of vaccines, or are we going to reduce the production time? So this is where we look at the data sources available and discuss with the business owners and with data engineers like Farah, how we're going to address the problem. Once we have figured this out, we start modeling, which is the next phase. And this is when you probably heard of fancy algorithms such as random forest or decision trees. So this is when we apply algorithms to actually fit to the data and to be able to build predictions into the future, which will enable us to determine how much production a client might make in the future and to determine what drives this production. So you might get some indications such as temperature, some specific areas of temperature might enable you to increase your production. Many combinations of factors will come into play. And this is really also a very important stage where we interact with Farah and other business stakeholders to determine how to better build these drivers and derive insights from our models. And finally, the last stage, which is fascinating because this really is where we see the impacts of our work, is when we implement our models and test initiatives that we see come out from our models. So the ones which I mentioned, which are setting temperature or some specific machine settings within some specific ranges, ensuring that the process is well followed, etc. So this is very important. And finally, we also upskill our clients. So we also interact a lot with them to explain to them what our approach is and how they can continue applying it when we've left them, so that they become completely autonomous and really understand the full process. Right. So I think in the next slide, I will go very, very quickly on this one because I'm aware of time. And also because Farah explained, we collect data and we analyze what data sources are needed in the first scoping phase. So Farah here would have identified, I don't know, 5 to 6 different data sources. What I enjoy about this slide is that as on my project, which I'm talking about here, the data sources really relate to actual production. So you see we have a data source about production of batches. So we will see how many medical devices have been produced each day. We can relate to this what the machine settings were on the production line. So what the temperature was, what the steering speed was, if there were any incidents on the lines, what were the shifts, like what employees were working at what time. And putting all these data sources together really enables us to then ingest this data, have a master table, and this is where we transition from data engineering to data science. But as Farah mentioned, this requires a lot of interaction and dialogue between the different roles, data engineers and data scientists. So if we go to the next slide, which is when we determine what drivers we want to analyze in the data. So here, in this situation, we have collected all the data we need, and we're trying to figure out what information we need to derive from the data. What signal should we decipher from this? On the right-hand side, you can actually see an actual chart that comes from raw data, so from initial data from the system. And as you can see, it can be a bit noisy. If you put this directly in a model, the model will not give you a lot of information. So just simply using algorithms will not be enough. We need to use the expertise and Farah's help to be able to build features to put in our model. And this is where we really spend time deriving what calculations we want to build. Once again, between data engineers, business owners, and data scientists. So maybe next slide. We have also been talking a lot about pipelines. And pipelines can apply to data transformations, as Farah mentioned, but it also applies to modeling pipelines, which is where data scientists have maybe a more important role. Here, what you can see on this slide is a pipeline that is visualized with Kedro, which is the tool which is built at Quantum Black and which is open source, which Meryl started talking to you about. This is a great tool. If you have any time to look at it and test it, I really encourage you to. You could visualize exactly the same pipelines. And this specific pipeline here that you see starts from the master table, which is the table that has been processed by data engineers, and ends with model insights, model outputs. So this is why it branches out like this, because it has quite a few outputs to analyze. This pipeline actually enabled us to increase production of medical devices by 20%. So that's where we see the actual impact at the end in the implementation. And what I really enjoy about this project, which I'm telling you about now, is that it really illustrates how well we interact between the different roles which we had today. And the final thing which I like about this pipeline is that it also shows the non-linearities in all our careers, which is very well represented here. So I'll end on this note, and I'll be happy to answer any questions about our role. Thank you.
Thank you, Margot, for that very interesting talk. And hopefully we've demonstrated to you this afternoon just the many diverse ways that colleagues at Quantum Black use their technical skills to have impact on the broader world. Yes, we all love technology and we're passionate about technology at Quantum Black, but first and foremost, it is about the impact we can have on real life problems in the here and now, that I think inspires all of us and makes us really enjoy the job that we do. Now, we had a few questions in the chat that I will just pick up, and then I'll throw a couple of other questions to the panel. Somebody was asking about the opportunity to work remotely. Well, we've all been working remotely in Quantum Black for the last 6 months. And I think we have proved that it is perfectly possible to deliver the sort of work we do, the digital work we do, working remotely, which is great because our organization and our business has managed to continue during this difficult time. I think what we're hoping for as we kind of shift back to a more normal world is to maintain many of the benefits of remote working, the increased efficiency, the more time spent at home with friends and family that we all enjoy, but also get back some of the benefits of being in person and really creatively engaging with colleagues, sparking ideas off each other, working in teams and really feeling like we're working in teams on a daily basis. So at Quantum Black, we do have offices all over the world. So we're not just in London. So there are lots of places you can work as part of a Quantum Black team. We do have some colleagues, particularly on the engineering side, who do work mainly remotely and just visit the office occasionally. But I think our preference is a little bit more of a hybrid model where sometimes we're with our clients, sometimes we're working remotely, and sometimes we're together in the office. It really depends what activity we're undertaking and where is best suited for that. Someone else was also asking about our interview journey as a data scientist. Margot, do you want to just quickly talk through that?
Yes, absolutely. So the journey in interviewing as a data scientist usually has about 5 main stages. It starts with a first interview on CV by a recruiter. Then it moves towards a coding interview on HackerRank, which is the platform we use. You then have what we call a use case interview, which will essentially ask you about how you would plan and approach a problem that we actually had and that we had to deal with as data scientists. And then you follow up with interviews which are a bit more personality driven on your drive. And finally, eventually some final coding questions depending on the role you're applying to.
Thank you, Margot. Yep. So it is quite a rigorous assessment process. We are really focusing on your technical skills, but we're also looking for your potential, your problem-solving potential, how you think, because some skills can be taught on the job. So just trying to get the balance right between what you know already and the potential we think you have developed skills. And of course, we're interested in your people skills more broadly too. As several of the presenters mentioned, this really is as much a people game as a technology game, and we want people who display both attributes. And then the final question on the Q&A, which I'm going to, I think, ask Farah, but I'm not sure if it's a Farah or a Margot question, but what do we use to test our data pipelines?
Cool. Well, there's lots of different types of testing. So just to quickly sort of give you an idea, obviously there's a type of testing called unit testing, which is very, very small tests to check that every function that you've written into your code is doing what you think that it's going to do. And then you can, if you scale up the tests from that, there's integration tests, end-to-end tests. That basically checks that, you know, right from the beginning to right at the end of your pipeline, it's all working together smoothly. Like if you've edited one part, it hasn't broken something further down the line. So you kind of have to have a whole suite of different tests that test everything. And in addition to that, you also probably need to be validating the actual data that's outputted. So you'll have some sort of testing or validation on what the actual data contains to check that it still containing what you actually expect it to contain. So lots of different types of testing. I hope that's helpful.
And maybe if I might add, I know that Meryl was working on a product which we're currently using, which is called Kedro Great Expectation, which is actually a validation framework for that second application, which you just mentioned.
Tell us more, Meryl.
Okay, sure. Yeah. So Kedro is basically a tool that helps you build your data pipelines. And Great Expectation is a plugin on top of that. It's actually also an open source project. And it helps you create expectations about your data. So you can say, I expect there to be no null values in this column. So it means I need to have data for each entry. So it could be data about someone's home country. And if the home country is missing, you wouldn't be able to run the pipeline. So we put in some sort of test, like an expectation saying, if there's no home country, please tell me so I can go and have a look. So these expectations are essentially kind of helping points for you to figure out what do I expect from the data and what will cause my pipeline to break. And you will be able to catch it as soon as possible.
Thank you, Meryl. Very topical question, obviously. There was a question in the chat about entry requirements into Quantum Black and whether you need a postgraduate degree or whether you can enter with a bachelor's degree plus experience. I'll attempt to answer this. I think if I look at our most junior data engineering roles, we are taking individuals who've just done a first degree, perhaps with a bit of work experience at the entry level to be apprenticed in the ways we work at Quantum Black. When I look at data science, in general, we are looking for a postgraduate degree, often a master's degree, sometimes a PhD. That is because the type of work we're doing at Quantum Black, particularly on the algorithmic side, is often quite experimental. And we really want individuals who've had the opportunity to do some postgraduate study and really get comfortable with that kind of experimental approach to solving problems. Would you agree, Margot?
Yes, I would definitely agree. I think it makes sense to have a sort of research experience, which you would have if you've done a master's degree.
So what I would probably suggest to somebody who was perhaps thinking about a route into working at Quantum Black is look at the many really great masters in machine learning programs that exist in a lot of good universities these days. They're usually one-year programs, and they can be used as a very good, I think, sort of conversion mechanism from any either computer science or maths or even physics or some other STEM subject degree as an entry route into Quantum Black or similar organizations. We work with a number of universities that deliver these programs. They're excellent programs, and I think they can be a very good way to get your skills to the right level to make entry into organizations like Quantum Black feasible, or go out there and get some work experience, whichever appeals to you more. And then, okay. Perhaps the question is about how the data engineering process, and particularly from a coding perspective, differs from the data science the process that Margot set out. So maybe, Farah, you could talk a little bit about your interview process.
Sure. In a lot of ways, it sounds like it was similar to Margot in the sense of there's some HackerRank coding tests, and in that it was kind of focused on knowing the basic Python functionalities. I think there might have been some SQL, but maybe it was all Python. I can't remember. But it was basically the basics of some coding. But then the interviews progressed, I guess, definitely into asking me a bit more about infrastructural things. So maybe that's a difference to data science, I'm not sure, but it was about knowing about different ways of storing data, different softwares that you can use, different programs that are out there for doing pipelines, any experience experience in using cloud technologies, that kind of thing. So maybe there's a more of a sort of infrastructure architectural aspect to data engineering interview process. Margot, I don't know if you have any comments on that.
Yeah, I'll just confirm this. I think the main difference is on this infrastructure side, and maybe we focus more also on the problem solving and business aspect, which we have in the use case interview. So that's where the split would be, I think, yeah.
But both roles, I think, rely on a high proficiency in coding. So I guess if we were to give any advice to anyone thinking about a career as a data scientist or a data engineer, use every opportunity you can to practice your coding skills and get really good at that. I think we've more or less run out of time now. I wanted to thank you all for joining us today. It's terrific to know that we've got some women on the line that are really interested in pursuing careers in this field. It's also great to know that we've got some teachers watching us too, who are working so hard to inspire the next generation to get into our field. Which is so important for the reasons I said at the start of the presentation. We need more women in data analytics, in technology in general. It's such an exciting, rich, growing field, and at the moment women are seriously missing out. So please, please, please carry those words forward with you, and thanks again for joining us today.
Thank you all.
Thank you.
Thank you.